I am confident that there is somebody taking over and watching over my key. So there is, if something happens, there is somebody that will take care of him. No matter if I am there or not, I can be sure that everything will work. My name is Jorge Morales, and I will talk to you about what are operators, why you should care about operators, how they work a little bit, and I will introduce you a little bit about the ecosystem around operators. So creating scaling stateless applications on Kubernetes, it's really easy. The only thing you need to do is kubectl scale your application, the number of replicas that you want, and Kubernetes will take care of it. So Kubernetes is a declarative platform. It will look into what is your desired state of your application. It will look into what is the actual state of the application in the cluster, and if it doesn't match, it will reconcile it and it will make it happen. So it will look, it will make sure that the state on the cluster looks as you are expecting it to be. But what about stateful applications? What about those applications that have notion of a cluster, that they have some specific kind of state? For example, databases. Running databases on Kubernetes is also easy. You do kubectl run, the name of your application, and it will run. But the problem with databases comes when you want to run those databases over and over time. So over and over again, and you need those databases to be up and running for a long time. This is much, much harder for Kubernetes. So there is a lot of things that this type of software will manage in a different way from software to software. Things like backups and restores, things like healing your application, reconfiguring your application, or even resizing and upgrading. If you think about, for example, one specific type of database, when you go from version X to version Y, you might need to do a full backup of your application. You may need to roll out one instance at a time, making sure that everything gets automatically or upgraded in the proper way. This is not easy, and Kubernetes doesn't provide a way to do it in an easy way. Okay, so every application on any platform, they have to be installed at least once, but they need to be run, configured, and managed, and upgraded over time. And more importantly, patching is really critical to security. So you need to make sure that every application that you have running in production, it is perfectly up to date, so it doesn't compromise your business. Anything that is not automated is slowing you down. That means that every time you have a human taking an action to upgrade your software, to heal your software, all of those actions are putting some overhead in your whole application delivery lifecycle. So everything that can be automated should be automated if it's possible. Okay? So what if Kubernetes knew how to do this itself? So just think, there is this guy. This is a fictional guy. Okay? He's a DBA. He's been working at a database company for 20 years. He's got a lot of experience. How many of those do you have at your company? Maybe one, maybe a few. Usually these guys are really scarce. It's not easy to find them. And when you have one of these, it is usually very difficult to get some of his time. Most of the time, you are asking, hey, I need the DBA to come to help me with my project. And guess what? They tell you, okay, in a month he will have some free time to go and help you out, create that database that you need, that your project needs. That's not easy. So what if we can have whatever this guy knows, how to create databases, administer databases, monitor databases, upgrade databases, heal databases? What if we put all of this knowledge into a box? Just think about what are containers. Containers are boxes that we can package and we can provide and we can ship. So if we were able to have all the knowledge that he has into an application, into a container, we could just deploy this application, this guy, this knowledge into every single company So you will be able to have databases running in production without the need to have one specific operational guy, DBA, working for you. So if the database company that provides you and knows how to do all these specific things with the database, gives you software that knows how to monitor and upgrade and precise and everything that you require, you will confidently run this in production. So operators are just automated software for running applications or Kubernetes applications. They provide install and lifecycle for your applications. So that means that they help you with installing, but not only that, they help you with the full lifecycle of your application. That means that once you have installed it, it will be managed and it will be taken care by the operator. Your application will be taken care of by your operator, the same way as my kid is being taken care of by my wife. So what is the recipe? The recipe for this is, and you have probably heard it in the keynote, what the capabilities that Kubernetes provide for extension. So that means that Kubernetes initially was meant for orchestrating containers, but with time, they realized that it was really needed to provide more capabilities into Kubernetes. That your applications at the end were probably being able to run as native Kubernetes applications. So with that, it came something called the CRDs, the custom resource definition, and the controllers, that all of that working in a specific way, they are known as operators. Although the Kubernetes is just, the technology that is used is just very plain Kubernetes. So the parts that are specific to an operator is a controller that runs inside Kubernetes cluster, and this controller is the one that is going to make all the, or take all the logic for your application. And then there is a custom resource definition that models the application that you're going to be running. It doesn't really need to be an application. Most of the times it will be an application, but sometimes it will be just an action on an application. Maybe you can model as a custom resource definition, making a backup or a restore. Like we saw in the keynote, there is the PVC snapshots. They are modeled as CRDs. So you can model as CRDs not only applications, but actions that need to be taken by an application. Once you have that definition created, what you do is you create one single instance of that CRD, which is a custom resource, and you deploy that one into Kubernetes. When you deploy it, the controller, what it's doing is it's monitoring the cluster, the etcd database, for some changes on not only this specific resource, but maybe some other resources that are important for your application. Maybe config maps, stateful sets, maybe secrets. So you can create in your controller all the logic that is required for your application to be run over time and to be managed over time. Just think, for example, if you change the database for the password for your database, you want this controller to be able to upgrade all your databases that you have deployed to have the new password. So the operator will make sure that everything that needs to happen, not only by the resource that you define, but also by all the resources that compose your application, are being eventually reconciled. So there is a set of open source projects that fall under the operator framework, which is an organization. Operator framework is an umbrella for operator-related projects. In this framework, there is one project which is really key to having or running operators in your cluster. At the end of the day, what is an operator? An operator is one application that is running on your cluster. But if that application is running on the cluster, how do I upgrade my operator when it comes to, hey, I need a new version of my operator because there is more logic that I need to put into it. So there is one project that is called the Operator Lifecycle Manager, which is an operator for operators. So what it will make sure is that it can, if you have operators running, if you have a new version of that operator, it will roll out that new version of the operator. That means that your application will not change. The only thing that is going to change is the operator that is managing your applications. This operator also has the ability to be able to upgrade the operator lifecycle manager, be able to upgrade your operators whenever you decide, or in an automated way. Why? Because, as I said, automation is critical. So you can decide, hey, I want to apply, whenever there is an upgrade for an operator, I want to be automatically updated. You do that with your phone. You have probably your marketplace having automatic updates for your application in your phone. So this is the same thing. You can have that for your cluster. You can have, every time there is a new version, you can have it applied. There is also, I just mentioned the word marketplace, there is also a project called Operator Marketplace that allows you to have a central place to have all your operators in a graphical way that allows you to interact, allows you as a developer to consume the operators. Why? So at the end of the day, one of the things that operators are is software that usually will be consumable by the users of your cluster, most likely developers. That means that if you have an operator that knows how to create instances of databases, there will be probably developers creating instances of those databases. Those developers need to have an easy way to consume those databases, to create an instance of that database in the way they want. And developers, guess what? They usually like more UIs, they usually like more easy of use than what admin or operator guys like. So they don't like huge command lines, they like to be simple. So there is a whole set of operators out there. There is an ecosystem of operators growing and growing and growing. And there's been a few companies, Google, Microsoft, AWS, and Red Hat, that they have met together and they have decided to have a central place for distribution and curation of these operators. So there is an operatorhub.io where you can go and find a lot of these operators. And this marketplace is integrated with the Operator Lifecycle Manager as one of the sources. So whenever you deploy the Operator Lifecycle Manager, it will tell you, hey, I can get operators, or I can feed my operator source from this operator hub.io and have them automatically displayed. If you also have the marketplace, they will be visible for your developers, for your users. So it's a fully integrated ecosystem. And then last piece, or one of the last pieces that is metering. Why metering is important is because when you have databases, for example, as a service, when you are allowing your developers to create instances of the databases whenever they want, you also want to track how much they are consuming of those databases. Why? Because sometimes the software that they are running is not open source, it's not free to use. You need to pay for whatever that you are consuming. So that means that you need to be able to track how much of these databases they are consuming. So whenever you need to probably get in contact with the vendor and make a conciliation, you can have you can know who to ask for the money. So how do we build your own operator? What if you want to build your own operator? We saw in the keynote one way of building it with KubeBuilder. There is another in this ecosystem of operator framework. There is another project called Operator SDK. The Operator SDK is very similar to KubeBuilder, but is providing all the expertise that a company like CoreOS, who were the initiators of the operator pattern, and Red Hat has been putting into how to build your operators. So what is the Operator SDK? At the end of the day, same thing as we saw. There is one command line to scaffold your project and to create a skeleton with everything that's required. All your sources will be there, all your makefiles, all your operators. And then there is extension points for you to provide all your capabilities into the logic. That means that if you want to define a new resource, it will provide you all the extension points to watch this CD for changes on that specific resource, to create, reconcile all the resources that you are watching. And then, another thing that it provides also is a set of APIs and abstractions to be able to deal with Kubernetes. Why? Because Kubernetes is a really complex platform, and there is a lot of things that you will need to do while you are creating an operator. For example, watching the etcd for changes that under the hood, it's really complicated. So these abstractions provide you with an easy way to interact with Kubernetes for everything that is related to building your own operator, creating your own application that will manage your applications. This SDK also provides the ability to, from Ansible, if you are an Ansible company, it will allow you to provide a playbook, and from that playbook, create an operator. So there is a lot of people that comes from automation that already has Ansible playbooks, so it's really easy to create an operator out of them. But not only that, as we saw, operators, one of the things that they do is install and manage the lifecycle of your application. There is a package manager called Helm that provides you with a description of what is your application. So this SDK also provides you a way of creating an operator from each of your Helm charts. So you have a chart for deploying your whatever MongoDB database. You can just, if you already have that chart, you can just wrap that up into an operator. And the good thing is that from the operational code that is generated, then you can use the rest of the SDK, the libraries, the abstractions, to expand, to go beyond the installation process that Helm provides into the full life cycle of or management of your application. And with that, I thank you very much for coming, and I will be around at the Red Hat booth if you want to make any questions, have any questions. Thank you.